So your exploration here, and I'm going to skip around a little bit, but yesterday what we did is we looked at the unit circle and we talked about what a radian was. So a radian is the ratio of the number of radii it takes to complete a circle. It's where we get the word pi. Remember, we talked about if you have a circle and you take this radius, let me give it a different color really quick. Just a quick recap, that it takes 1, 2, 3, and a little bit more, and that little bit more happens to be 3.1415, blah, 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 radians in 180 degrees. So really what we're doing is when we put this in terms of pi, instead of saying 3.14, we say that this is pi radians. And what we can start doing is using our knowledge of fractions to kind of help us plot these pretty quickly. So for example, if you know pi is going to take you to 180, I know that pi over 2 is going to be halfway there. Now it says to state our reference angle if there is one. Remember that our quadrantals do not have reference angles, so pi or 0, pi over 2, pi, 3 pi over 2, and 2 pi. No reference angle, because there is no acute angle that goes to the x-axis. So let's look at number 7, 5 pi over 6. We should notice that 5 pi over 6, if I'm thinking what's like 5/6 of the way, so I know that if this guy is all the way, I know that 5/6 of the way is going to be about right there. Now 5 pi over 6, we are missing 1/6 of the way. 1/6 of 180 is 30 degrees, so our reference angle, let's call it theta, is going to be 30 degrees. Checking out one more before you guys get going. 5 pi over 4. I know that 5 pi over 4 is about 1.25 pi, so I'm going 1 and a little bit more. So that's going to put me at my 5 pi over 4. So I know that if this guy right here is 4 pi over 4, that we are pi over 4 more, or a fourth, and a fourth of that 180 gives me a theta of 45 degrees. Take a second and work through all of these. Once you check your answers, if you are good to go, then close out of this. If you need for me to keep on going through, keep on going through. So you should have gotten things that look something like this. So pi over 6 is about 1/6, my reference angle is 30. Pi over 4 is 1/4, my reference angle is 45. Pi over 3 is about a third of the way, right? So if we go 1, 2, 3, then that's going to be a reference angle of 60. Pi over 2, remember no reference angle because that's a quadrantal. 2 pi over 3, 2/3 of the way. My reference angle is going to be 60 degrees because I'm missing, to get to that x-axis, I would need pi over 3 more, and I know that 1/3 of that entire distance is going to be 60 degrees. 3 pi over 4, we know that that's 3/4 of the way, so our reference angle is 45. 5 pi over 6, our reference angle is 30. 5/6 of the way, right? We only have 1/6 to go. 7 pi over 6, reference angle is 30 again. Remember, we're going pi over 6 or just 30 degrees more than that 180. 5 pi over 4, thinking that that's 4 pi over 4 plus 1 pi over 4. So remember, we're going up 4/4 and then we're adding that 1/4, and there's my reference angle. 4 pi over 3, remember that's going 3 pi over 3 and then adding that pi over 3, so that reference angle is 60. And then 3 pi over 2 is a quadrantal. Quick recap right here, you guys, is you should start noticing a few patterns. Every single time I have a pi over 3, so there's a third, there's a third. Where else? There's a third. My reference angle is 60. Every single time I am given a fourth, my reference angle is 45. Every single time I'll let you guys figure this one out on your own. But every single time I'm giving a sixth, I also have a similar reference angle. We're 1/6 away from my closest x-axis. So just starting to make some connections here.